space is there, that space, this is orbit actually. But the probability of electron is what? 95% here. This space is having what? This is orbit path actually. In this path, what happened? The probability of finding the electron is maximum 95%. So you are calling this one as orbital actually. An orbit represents the movement of electron in the one plane like this. It is moving like this. Electron is moving like this. So this represents. An orbital represents the momentum of electrons in the three-dimensional space. On which space it is moving actually? X-axis, Y-axis, or Z-axis? Like dxy orbital, dy orbital. You are explaining no. So how many d orbitals are there? 5 orbitals. How many p orbitals are there? 3 p orbitals like that. So they are explaining what three-dimensional space here. Which one? Orbital. The orbit explains the momentum of electron. Orbit explains the momentum of electron like this here. Whereas orbital explains what happened, the three-dimensional space where electron located actually. Next, an orbit means the position as well as the velocity of the electron can be known with certainty. Orbit generally what happened, where it is the position, and also what is the velocity of electron generally we find that. But orbital, if you observe what happened, it is not possible to find the position as well as the velocity of electron cannot be calculated by the orbit. Orbital is only what happened, three-dimensional space actually. So we can't calculate the velocity of electron by using the orbital. Orbits are circular paths like this, or elliptical path like this. Where orbitals will have some shapes, spherical shapes, dumbbell shapes like that actually. Orbits do not have direction. No direction because they are in elliptical space. There is no x, y, z axis here. Or except s orbital, this is non-directional, but remaining all are what? Directional in nature. This is very, very important. They are asking this question many number of times. An orbit can have a maximum number of how many electrons here? 2n square. The formula to calculate first orbit, how many electrons you are having? 2 into 1 square. Second orbit, how many electrons you are having? 2 into 2 square. Like that, the formula is there. You can easily calculate. Orbital will have what happened? Any orbital, if you have, it can have only 2 electrons. You can place in any orbital only maximum 2 electrons. Now, this is about the difference between the orbit and orbital. Now, let me see the energies of orbitals. Energies of orbital. The energy of electron depends upon what character? It depends upon the principal quantum number n and also depends upon the azimuthal quantum number. The energy of generally depends upon n and l values. So to calculate the energy of any orbital, it depends upon n and l values here. For multi-electron, then for having what happened, many number of electrons, they have some type of forces will be there, attraction forces between the electron and the nucleus, and the repulsion forces between the electrons and electrons that may also influence. So in this energy, in multi-electron system, that means having more than one electron, in which what happened, the attractions between the nucleus and electron and the repulsions between the nucleus, and that means electrons and the electrons will also influence actually. Now generally what happened, we have to use this formula actually, n plus l formula we have to use. Very, very important formula. N plus l is what? Very, very important formula for us to calculate the energy. Whenever n plus l value is what? More, it will have more energy. If n plus l value is less, it will have less energy. Understood or not? Very simple. N plus l is less energy. N plus l is what? More energy. For example, I will take 3d and 4p. Not 3d and 4. 4s and 3d I will take. Now what is n value for this one? 4. L value for s orbital? 0. Total is equal to 4. Now for this one, n value is 3, whereas L value is what? 2. For d orbital, L value is what? 2. Total is equal to what? 5. Now which is more? 5. So 4s is what? Lesser than the 3. So if you know this one, you can easily write down this order of the energy. But one thing will be there. What is that one thing if you observe here? What happened? If you observe 4p and 5s. Okay, 4p and 5s. For this one, n plus L is equal to 4 plus 1, that is equal to 5. For this one, 5s, 5 plus 0, that is equal to 5. Now both are having 5 and 5. Now in this case, whenever n plus L is equal to same, in that case what we have to take? N value we have to consider. If n is more, that will be the more energy. Now in between these two, now 4p and 5s, both are having n plus L is equal to 5. Now what we have to consider? N value. Whichever is having more n value, that will be the more energy. Now 5s will be the more energy when you compare with what? 4p orbital. Understood here? Energy find out here. So in this way, we can easily find the energy. Okay. Filling of orbitals with electrons in an atom. The filling of electrons into various orbitals of different atoms takes place according to the Aufbau principle. And also what happened? Pauli's principle. And what? Hund's principle here. Hund's, Pauli's, Aufbau principles. These are the three principles generally be useful for what? Filling of electrons. While filling the electrons, what happened? These are the rules we have to follow actually. These are the three rules we have to follow actually. First, let me see the Aufbau principle here. In the ground state of the atom, the orbitals are filled in the according to increasing order based upon the n plus L2. That means when you are filling the electrons, first you have to fill what? Lower energy, then we have to go for what? Higher energy. First we need to fill lower energy, then we have to fill what? Higher energy. How you climb the steps? Lower to higher. So whenever you are filling the electrons, you have to fill from lowest energy to highest energy. For example, I have to fill electrons in 1s, 2s and 2p. Now you have to take what happened, which is lowest in this case. 1s is the lowest one, 2p is the highest one. Now I have to fill the electrons from 4s, 1s to 2s. After filling 2s, I have to go for what? 2p. So whenever you are filling the electrons, first we have to fill what? Low energy, 1s orbital. Then what happened? High energy, 2s orbital, isn't it? So in this way, we can write the definition of Aufbau principle. The definition of Aufbau principle is second point. This is the second point. So in examination, they're asking Aufbau principle. So what you have to write? Electrons occupies first available lowest energy level and then only enters the highest energy orbital. Otherwise, simply you can write like this. Electrons enters in orbital from lower energy to higher energy. In this way also we can write here. This is called what? Aufbau principle here. So you observe this diagram. First one, these are the orbitals. Many number of orbitals are there like this. These are the orbitals. All these are the orbitals actually. So first I am writing all the orbitals here. All the orbitals like this. So these are the orbitals. Now first I have to fill which one? 1s. Then 2s. Then 2p. Then 3s. Then 3p. Then 4s. Then 3d. Then 4p. Like this you are having the diagrams like this. So this is called what? The diagram. The model for what? Filling the electrons in the orbitals from lower energy. From one, which orbital? 1s to, isn't it? 10s here. Okay. Order of increasing energy of sublevel. See, this is the order. You just observe this one. 1s to. If you have any doubts, follow which rule actually? N plus L rule we have to follow. If N plus L is what same, N must be what you have to consider. If N is what more, that will be more energy. I think you understood this one. Very simple it is. Plus 2. So here it is there. Case 1. If N plus L value is different, then whichever is having N plus L is equal to more, that is what? High energy. You have many number of examples. I will send this one in the PDF format. You just calculate the energy section. So here many number of examples are there. Okay, find out this one. Just all of you observe the PDF formats. In case 2, if N plus value is same, whichever is having highest N value, that will be higher energy. Whichever is having lowest energy, N value, that will be lowest energy. See this thing we have to observe. Observe this one. 2p and 3s. For 2p, N plus L value is how much here? 3. For 3s, N plus value is what? 3. Both are having 3 only. Now, N value for 2p is 2. N value for 3s is what? 3. Therefore, we can write 2p is lesser than 3s. In this way, we can easily carry. All these are the problems we can do here. By observing the PDF format, we can get that. The number of orbitals are given here. Any number of orbitals. We are having what? N values are there. L values are there, N plus L value. So what is N plus value for the 4p? 4 plus 1 is equal to 5 like this. You can easily get. These are some examples for you. Order of filling of electrons. Now this is the diagram. 1s, 2s, 2p, 3s. Why it got down actually? Because this value 4 plus 1, 3 is equal to 5. That is the less value you are getting at 4. This is what less value, no? 4 is what less value, no? This is the less value actually. Next, shall I continue? Otherwise, what happened? Hund's rule we'll discuss in the next. It's better. Shall I continue? Otherwise, Hund's rule and are there. Shall I take? Shall I put in videos on YouTube by making?
Sir, next class, sir.
Okay. Next,
Yes, sir.
Next class means I will do one thing actually. I make video and I will put in YouTube. Okay. Remaining topics are left only what? That Hund's rule and one more thing, Pauli exclusion principle and energies something exchanges are there. That I will make one more video. I will put on YouTube. By tomorrow I will put that. Okay. But on Wednesday you have to write exam. And if you have any doubts, you can stay with me. Otherwise, you can log out now.
Thank you, sir.